on the Blackboard conversation.
Mm-hmm.
It's like transistors or something.
Yeah.
A circuit diagram.
I love how this looks so different from
Thinking
what
like
we
Lee
do.
algebra is like Hopf algebra, it's like the trees. The messes.
Oh, you know, it's already too complicated.
That's all, it's a bunch of Ks.
Alright, so this is a TRIUMF person, and this is an artist. Alright, so they interact and that ends up producing one piece of work here. Alright, and then what's going to happen is this is going to end up being blind here. Then once the artist has shared their piece of work, they come back and then talk to a TRIUMF person again.
Mm-hmm.
So you're, once you've presented something to somebody and they go in blind, then you go off and talk to a TRIUMF person again. So,
And what's the benefit or the purpose of that?
well, it then allows you to, after you've produced a work blindfolded, you go back and see what it was originally, and then you might make a new piece of work to see, well, how
So
much
you're
you
saying the
change.
blindfolded artist makes the work and then gets to talk to the physicist?
Then gets to talk to this and makes a new piece of work. So then you can compare the new unblinded art to the fully blinded art as it propagates through. So there's,
Might also be more like credit, of a gratification for the artist to get feedback right away. Instead of giving the work away and then waiting,
Right.
and then maybe losing track of their own
Right.
work.
Mm-hmm.
so it does mean a single artist will get more pieces of work done, and a single artist will have an opportunity to be both blinded and not blinded, which they may or may not like.
Look like as a Feynman diagram, but just let the interaction happen as they, well, you know, like either we define how you interact or they make up their own interactions as they go, but keep track of what they were,
yeah.
what date and what time, because then, you know, you would have your time, maybe this one has a really long time in between interactions and then very short, you know, interactions here, and, because then you could map it out like you have it, but have the, you know, the way
That
that.
definitely would be interesting.
Nice to have the
Yeah,
record.
It
Yeah, have
certainly
the
would be very
record and-
useful for
yeah.
when you're doing the second years.
Yeah,
Because then you could
yeah.
potentially
Let's see, yeah.
feed that to so basically I end up just drawing Feynman diagrams here. Let me just draw a few on. The point is, this is a physics process somebody like me would study in their research. And so particles come in, they interact to make a new particle, and then those particles come out to make all these other ones in the end. So these are the ones you actually end up seeing at the bottom in your detector, but these are the ones you actually cared about at the start here. Now, as people would go through this, you wouldn't say that such and such people are certain parts of the lines, but at each interaction point here, an artist would speak to a physicist, and then based on what's happening in this diagram, they'd say, oh, your next piece of art should be related to the particles that are coming out. So, for example, here, here you've got coming in with a piece of art, and then you're meant to come out with two different pieces of art. One which is going to be related to electrons, a type of particle, and one which is related to neutrinos, which is a type of particle. And so the properties of those particles should influence the art. So you might say here, because it's electrons, it should be, you should make a piece of art that's related to electricity somehow. And here, the piece of art, because it's related to neutrinos, should somehow be invisible, being hard to interact with. And so the properties of the physics process would tell you about the next piece of art. But then there could be some feedback too. So when an artist gives their art to the scientist, the properties of the art may influence what the physicist tells them to do next. So particles have properties just like the art has properties. You might say a piece of art is very energetic, all right? And if a piece of art is energetic, maybe that would translate to a particle being energetic. And if a particle has a lot of energy, then the physicist can calculate something and say, okay, well then the next piece of art should be like this or be like that. If you say your piece of art is, you know, very heavy, very massive, and just dominating, that might change the way the next piece of art should be produced based on the physics.
And do you imagine that there are a lot of physicists here who would be perceptive and able to?
The scientists look at it and they say, okay, well, this would mean I have to invent a new particle to explain such and such in the piece of art. Or the experimental say, okay, well, assuming it's not something new physics, how can I explain it in terms of the detector went wrong? How can I explain why such and such has gone wrong in this art data? And then they'd all come back out and the artists make a new piece of work and they come back together and just constantly interplay with each other to see how they can force each other to make new pieces of art and new bits of science.
How long